Hello grade 9s, hope you all are well. Welcome to today's video lesson. It does feel a bit like a Wednesday now that we're back in some type of teaching routine, and I hope you guys are coping with all the videos and worksheets that are flying your way. In today's lesson, I'll be doing the solutions for the homework that I sent out on the 11th of May. That will be in the first video, and in the second video we'll be doing some more examples on perimeter and area, this time from your grade 10 textbook. You'll notice that the worksheet that I sent out was from a different textbook. And the questions from the worksheet that were for homework were question 2 and question 4. So question 2, this is a diagram of the floor in a house. It will be covered with square floor tiles that measure 20 centimeters by 20 centimeters. Now, the lengths of the sides in the floor plan are given in the unit meters. So that means when we work out the area of the floor plan, we're going to get meters squared. So the first step in this kind of problem is to find out how many 20 centimeter by 20 centimeter tiles fit into a 1 meter squared block. So I've drawn it here. We have an area of 1 meter by 1 meter, and because 5 times 20 centimeters equals 100 centimeters, which equals 1 meter, I can split this side into 5. And then for the height, I can also split it into 5 because it's 1 meter. So each of these jumps is 20 centimeters, so it goes 20, 40, 60, 80, 100. And each of these is also 20 centimeters, 20, 40, 60, 80, 100. So each of these tiles represents 20 centimeters by 20 centimeters. So how many of them occupy a meter squared? Because it's 5 by 5, that would mean that there's 5 by 5, which is 25 tiles per meter squared. Okay, so now I'm going to find the area of the floor in meter squared, and I'm just going to times it by 25. So let me draw this floor plan again. We've got 2 meters, 2 meters, 3 meters. This side is not given. 1.8 meters. 6 meters. 2.4 meters and 1 meter. Okay, to find the area of this shape, I'm going to split it into 3 different rectangles. So like this. So the dimensions of the top rectangle are given. We have a length times breadth. The bottom rectangle is also given. We have a length and a breadth, and we just need to find the dimensions of the middle rectangle. So this length is 2.4 meters. Let me just put this 1 meter so it's not confusing. So this is 2.4 meters, this is 1.8 meters. So that must mean that this length here, needs to be 0.6 meters. And that's because 0.6 plus 1.8 gives us the full length 2.4. Next we need this dotted line. So because this length is 3 meters and this is 1 meter, the missing piece will be 2 meters. 2 meters plus 1 meter gives us 3 meters. So let's find the area of each. I'm going to call this rectangle 1, rectangle 2, rectangle 3. So for 2a, that's to find the number of tiles. Area of rectangle 1, it's 6 times 1.8. That's 10.8. And don't forget our unit, meters squared. Area of rectangle 2, it's going to be 2 times 0.6, which is 1.2 meters squared. Area of rectangle 3 equals 2 times 3, which is 6 meters squared. And now the area of the total floor plan, I'm going to denote that by A, is going to be the area of each of the rectangles added together. So area of rectangle 1 plus area of rectangle 2 plus area rectangle 3. So just notice how I've laid out the solution for this kind of problem. I've broken it up into parts. Now, if you understand this really well, you might be tempted to just do everything in one sum. Now, there's a danger in that, because if you make a mistake, you can get the whole thing wrong. But if you've broken it up and you get some of it right, if you get some of these rectangles right, then you will always get some marks. So that's why I've unpacked it like this in little chunks. So the area, we're going to add all of these areas for the rectangles. It's 10.8 plus 1.2 plus 6. So that gives us 18 meters squared. And now we say that in every meter squared there's 25 tiles. So the number of tiles is going to be 18 times 25. So each meter is 25. So we times them. 18 times 25 is 450. Okay, so that's for 2A. 2B says each tile costs 13 Rand. Find the total cost of the tiles that are needed. So there's 450 tiles, each one costs 13 Rand, so our total cost is 450 times 13, which gives us 5850, and don't forget our unit rands. Okay, so that's the first question I asked you guys to do. Next question, question 4. Okay, so question 4. A flower bed has parallel sides of 2 meters and 3 meters and a height of 1 meter is cut out of a rectangular lawn that measures 9 meters by 6.5 meters. So let me read this question again. A flower bed that has parallel sides of 2 meters and 3 meters and a height of 1 meter is cut out of a rectangular lawn that measures 9 meters by 6.5 meters. So there's a rectangular lawn around this, which is 9 meters and 6.5 meters. Okay, so for A, find the area of the flower bed. So we must find the area of this thing. So this is very similar to the example I did in the previous video lesson. We're going to split this shape into a rectangle and a triangle, and then we can use our area formula. So these two sides are parallel, so it's a rectangle, and because it's a rectangle, that angle will be 90. So this is a right angle triangle. if this long side is 3 meters and this short side is 2 meters, that must mean this little piece is 1 meter. Okay, so 2 meters, 2 meters, the opposite sides of a rectangle are equal, and then we need 1 meter to add up to give us the 3 meters. So now we've got all the dimensions for the shapes we need to calculate. So the area of the triangle equals a half times base times height. So because it's a right angle triangle, the height is going to be this side by the 90 degrees. Sorry, I missed 1 meter. This side is going to be 1 meter as well. The opposite sides of the rectangle are the same. So let's plug that in. We've got a half times 1 times 1. So that's a half. And our unit is meters squared. Now the area of the rectangle equals to length times breadth. So we've got 1 meter by 2 meters, 1 times 2, which is 2 meters squared. So now the area of the flower bed equals the area of the triangle plus the area of the rectangle, which comes out to 2.5 meters squared. Okay, next find the area of the lawn that is left. So this shape was cut out of the rectangular lawn. So to solve this, we first find the area of the lawn, and then we subtract the area that was cut out, the area of the flower bed. So let's first find the area of the lawn. That equals to length times breadth. That's going to be 9 times 6.5. I get 58.5 meters squared. The area of the flower bed was 2.5 meters squared. So notice that, you know, these diagrams are not really drawn to scale. It's just theoretical. So we've got the area that is left. It's going to be the area of the lawn minus the area that's cut out, the area of the flower bed. So that's 58.5 minus 2.5, which gives us 56 meters squared. Okay, so these examples were relatively straightforward, just to start off the section, and in the next video we'll be going over slightly trickier examples from your textbook.